So some of you probably are, familiar, or some of you may even be tired of the IBM Smarter Planet ads. We've been talking about it for 4 or 5 years now, and it's a very compelling vision. It's a vision that I believe was IBM worthy in terms of our view, our CEO's view back then in 2008, that the world is getting more intelligent, instrumented, and interconnected, and as a result, there's a whole new set of IT capabilities that will come about. And as we started doing these engagements around enabling the smarter planet, so everything from toll booths to railroad cars to expensive jewelry to IP sockets, bulb sockets for getting data, and information was coming out of every source. And our view was there is a whole new class of IT systems that will be built to leverage that. What we quickly learned after having done over 20,000 engagements around the world is that the basis of a smarter planet rests on data and analytics. People call it big data, people call it big data analytics by various names. But what was our realization in the last 4 years is that data is where sort of the puck is going to be. And what we are seeing is data is coming in as a multiple sources. Tom spoke about mobile, I think one of the most rapid adoption that you've seen. Cloud, people are storing more and more stuff. Amazon Cloud has over 250 billion pieces of information stored in Amazon alone, right? So people are putting more and more stuff in the cloud, and they're kind of pulling that down. Social, people are sharing more and more information about themselves on Facebook and Twitter and Amazon. I don't remember the last time when I was online and I bought a product without looking at a review. Very different than how I used to do it 5 years ago. And that's not relenting. The LinkedIn and other stuff, that will keep growing at us. And lastly, this notion of Internet of Things. Like I said, toll booths and baby monitors and ultrasound machines, everything beginning to create data. The problem with all of this is it is not just about the data. What do you do with having the data, right? You can store it. In fact, in many of these cases, this data may not be the one you may want to store. If you have a US Open going on, or if you have a cricket match going on, given the audience here and the one I follow, you may want to just track that data for the period of time the event is going on. This notion of data at rest versus data in motion. Right? I call it the difference between fishing in a pond versus fishing in a stream. The nature of data is going to change too. So all this data that's coming out, people are not able to figure out what to do with it. But those that have actually good access to data and are able to drive insights from the data, we have found in our studies that they have better business results and better performance. However, we're also seeing that in popular media, this whole big data stuff, Dilbert's talking about big data. So now you know the big data has arrived. When Dilbert starts talking about how some of these technologies and some of the tools are being used by everyone out there. So Hadoop is something that a lot of people, I'm surprised, non-technical people, our business guys coming and asking me about how do I put a Hadoop-based cluster and how do I start getting value out of it. So the point of all of this is that it's not just about the data. Data is coming at it, people are willing to use it, but I equate the problem to one of businesses dying of thirst in an ocean of salt water, right? On one hand, you have a lot of information coming at you, but you're not able to consume it. People are saying, I'm sharing more about you, but businesses don't know how to use it. 90% of the world's information was created in the last 2 years. 90% of all of humanity's information. And that's doubling every 4 years. And here's the interesting part on how it starts connecting to Watson. 80% of that 90% is in a form that machines don't understand it today. It's not zeros and ones and data. It's semi-structured and unstructured data. These are Amazon reviews and doctor's notes and nurse's notes and call center notes, stuff that are opaque to a computer. Right? Ask a question of a machine. What is the initial dosage of antibiotics for a 7-year-old child with a history of asthma? Right? You will get back 4 million links from Google looking at the keywords. Watson will come back and say, 3 teaspoons 2 times a day, 82% confidence, and here are 4 sources of evidence. And by the way, I know that asthma goes by 17 other medical terms. 2 teaspoons 1 time a day, 42% confidence, here are 45 sources of information. Why? So there is this whole shift from keyword-based search to deep linguistic-based discovery. Okay? There's a switch from what I call as deterministic apps to probabilistic apps. Right? That's what we're going to start seeing over the next 5 to 10 years. Those little bars that you saw at Jeopardy, right? Each of those represented a confidence level of an answer. You're not giving an answer. If you ask Watson a question, 2 plus 2 equals 4, Watson will come back and say, yeah, I'm pretty certain that's the case. But it could also be 22% confidence, a configuration of a car, and 18% confidence, a family unit described by a sociologist. So the definition of how information is represented and captured and used is where computers are going to be shifting from just calculating stuff. I have this statement that I make that in time we will look back and say, computers before Watson were nothing but giant calculators. They knew how to process data fast. Computers after Watson began to understand semantics, syntactics, language, and we're able to enable a whole new class of decision making. We're able to democratize areas like medicine, and I'll show you how, and show you some of the results we're finding in there. So, in the interest of time, I'm going to skip this video so that you all can go home, and I know you have a 7:30 start, so I'll keep moving it along. A quick history of Watson. This came out as a part of IBM's IBM research program. We take on this thing called Grand Challenge. The last one we took on was Deep Blue, the chess-playing computer that proved that computers can calculate faster than human beings can. This one came out of the next program, which was Jeopardy, where we said, can computers understand human language? And we did IBM research, spent over $6 billion a year, from the largest math department in the world, and they took on this challenge. In Valentine's Day 2011, I was watching this in Austin, Texas with my family, not knowing that in 4 months from then, I'll get a call from my IBM CEO saying, go convert smarter to richer, right? Figure out how this smart technology can be put to work to change the world in terms of improving our societies and stuff. So I consider this to be the most meaningful startup in my life. I've been doing this for 2 years. I want to share with you some of the breakthrough results we've already seen in this short amount of time. So one of the first questions I had to decide was, this thing that we inherited was the size of my master bedroom, and I live in Texas. It's a fairly big master bedroom. And you look at it and you say it's a single user system. It has demonstrated Jeopardy. It can process 200 million pages in 3 seconds and understand the meaning of it. How do I put it to work? So the first area I had to decide was, where do I point this cannon, right? And what was obvious to me was information-intensive industries. Industries like healthcare, insurance, telecom, banking, education. These are great targets for a technology like Watson. I call Watson the desalinization plant. You have this ocean of data that you can't drink, and Watson can be put on top of it to start making sense of some of this stuff. So we said healthcare is where we start, and then we'll start expanding it into other areas. So why is it a big deal? You can ask the question, why is it that something like Watson is a big deal? And here are 2 examples of it. One is, you ask a computer a question, Welch ran this, and unless you have that information in a structured database under a column called person and organization, that's a very brittle query. However, Watson, which has all of Wikipedia, all of IMDb, has most of the internet stuff already stored in it, because we had to keep it local to play Jeopardy. We even had to have a mechanical thumb to play Jeopardy. Watson can read through and say, I read this passage in one of the Wikipedia entries that I can deduce that actually Jack Welch ran GE. Watson also understands the semantics, syntactics, the nuances of the human language. So it can understand that noses, how do we as humans figure out that noses that run and feet that smell? It's supposed to be the opposite, right? Watson also understands that a house can burn up and it can burn down, right? And then, when you start taking it into new domains, like we did in medicine, we had to train Watson on a whole new technology. Because doctors, while they speak English, it is very different than how you and I converse. So these are some of the challenges we have to say, I call it Watson at play versus Watson at work. When we started putting Watson to work, the first thing we had to do was give it a brain of a medical student. One of the things we're doing is at Cleveland Clinic, and after I got the job and got a big check to say start building the team, we hired about 107 people in the first 90 days across IBM, and we said, my motto to them was, think watches, not calendars. When I ask you something, don't look at your Lotus Note calendar, look at your watch, and tell me how fast can you do it. One of the first things we had to do was, how do we gain credibility in this field of medicine? So I set the goal, and I said, now that we have passed Jeopardy, the next logical goal is to go past the US medical licensing exam, right? And a lot of the research people, after they fell off the chair and some of them started throwing darts, they said, are you crazy, right? But guess what? Cleveland Clinic has been training Watson over the last 18 months to take on the medical domain. And while I won't give out the punchline, we are within striking distance of making Watson pass the US medical licensing exam. Okay? Completely new domain. This is again the power of a new class of computers that understand language and semantics and are able to now answer questions in a way that assists us at a whole different level of capacity than existed before. So the other thing I had to do was to figure out, what is this thing? How does it even work, right? Watson is one of the most complex systems ever built by IBM company. The last system that was more complex than this was System 360 back in the 1950s, which was a supercomputer. Spent over $5 billion for that time. What it does at the heart of it, and by the way, this is the single largest investment the software group has right now going on. I have a team of a few hundred people, but extended IBM team is probably about 800 people working on this. At the heart of it, Watson does these three things. It understands human language and natural language and communication at scale. Like I said, it can process 200 million pages in 3 seconds and understand the meaning of it. Number two, it evaluates and generates what I call as evidence-based hypothesis. Okay? Not only does it tell you 2 teaspoons 3 times a day for the child, it will also say, here are 14 sources. 2 of them are doctor's prescriptions, 4 of them are research articles, 5 of them are newspaper things that I picked up. They're all pointing to the fact that this should be the dosage of antibiotics, right? And also, I also use the word, bipolar or something, which may be another definition of asthma, because it understands that at a deep semantic level. Last but not the least, it learns with every behavior. A little funny story here. One of the things that came up in Jeopardy, there was a question, a category in Jeopardy came out, it said, chicks dig me, okay? Watson looked at the question and says, chicks dig me. What does that mean? Right? Is that a hen and a chicken gonna digging at something? But it didn't know how to interpret the question. It waited back and it waited to see what the first responder took as the answer, understood based on the answer that the first responder gave, and cleaned up the rest of the board. The machine could figure out, okay, this is the interpretation that this particular person is going down on. So the ability to interact and learn is another important capability of this new class of what we call as cognitive computers. This is all built on our Power 7 architecture. So just like Deep Blue gave us some architectures on power technology, now we're leveraging that into Watson, and now I'm working with the hardware team on our Power 8 and Power 9 architectures to say, how do we optimize storage, networking, processing around a workload like Watson. A lot of things that's going to be driven off of it. I'm not going to bore you with this, but at a high level, this just shows how the pipeline architecture of Watson works. A lot of stuff on this on the web that you can go through it. The essence of it is every question could be interpreted multiple different ways. Every one of them has multiple sources, multiple answers, and it's like an orchestra where a conductor is conducting with 90 different experts going at it in different models and being pulled together. So the question was obviously why healthcare? Why did we start with healthcare as the first domain to prove Watson's capability? And here are the reasons. Number one, medical information is doubling every 5 years. Right? So if you're a medical student, you go into your college, by the time you come back, everything that you knew has been doubled. Okay? At the same time, doctors were telling us they were spending less than 5 hours a month reading up on medical journals. Completely messed up my sense of security when I go to see my doctor these days. Right? Start Googling like hell and printing out like hell, saying, I better ask this question because I know this dude is not spending more than 5 hours a month. So we felt, and as a result, you see a lot of other issues with it. We saw 1 in 5, again, if you look at some of the statistics, it's stupendous. 1 in 5 diagnoses in the US is considered to be inaccurate or incomplete. Okay? 1.5 million prescriptions are prescribed in the wrong way, and so on and so forth. This is the largest industry we have, $1.8 trillion. Okay? So we said this would be a great industry to apply a technology like Watson as a doctor's assistant. Not to replace a doctor. I call Watson the GPS system for doctors. Right? It will give you the way, and you can interact with it, but you make the decision. It's not something that the machine is doing for you. So stuff like this, medical records. Companies are full of this data, but they're not able to read through because all of that, most of them, lab report, path report, nurses' notes, doctors' notes, is all in a format machines don't understand today. Watson can read through all of that stuff in 6 seconds in a large hospital, right, and tell you the meaning about it, if you have the training behind it. So here's an example of how this might come together. This, just stay with me on this a little bit because it's a little complicated. This is a medical record of a 58-year-old woman who has a history and who's got, who's come in complaining of dizziness, anorexia, dry mouth, and so on and so forth. This gets entered by a doctor, electronic medical record. It gets fed into Watson. Watson starts looking for what we call as PCI, pertinent clinical information. Starts saying, okay, based on what I'm hearing in the symptoms alone, that she's having difficulty swallowing, she's thirsty, has got anorexia, looks like flu to me. Then it reads further down and says, in addition to the symptoms, this is a family history. Okay? Her mother had Graves' disease, her sisters have this particular piece, and so on and so forth. And Watson starts looking and saying, okay, now that I superimpose the symptoms with family history, it starts looking like diabetes to me. Then you say, okay, just look at the history now. Over the last 3 years, she's been treated for these, with these medications, and this was the response to it. What do you think about it? So what you're doing is you're building a diagnosis model here, completely built on unstructured data. And in essence, what you're doing is capturing the knowledge of the world's best medical professionals into this system, which over time is getting smarter. One of the stories I like to say is, do you guys know who Alexander's teacher was? Aristotle. So Aristotle taught Alexander for 14 years. Wouldn't it be great if there was a way for us to go back and find out exactly what was taught and capture the knowledge so that humanity can use it? With Google, we have information about what I have done and what I have tweeted and what I ate on Foursquare and where I went, but it still doesn't capture my knowledge. Some people may not want to capture my knowledge. But the reality is, with the Google, we're leaving a digital exhaust and an information exhaust. With Watson, you can start leaving behind a knowledge exhaust. Okay? You're able to capture for blood cancer how the best trained medical people in the world would train diseases. And then you use that with technologies like cloud and mobile. You can start imagining democratization of medicine, not very far away. You're a kid in sub-Saharan Africa, and you come running to your father, and you got bitten by something, you don't know what it is. And all your dad knows is, all the dad has is a smartphone. Imagine taking a picture of that image and sending it to the cloud through a mobile network to Watson, who's looking at it and saying, this looks like an allergic reaction, or this looks like a spider bite, or this looks like a snake bite. Here's some information on what triage to perform, and here's the nearest doctor and the phone number you can call. Right? So this notion of being able to capture the world's best information and democratize it through cloud and mobile is what is the beginning of the big next shift in computing and in information technologies. So in the interest of time, I'm going to move along. This is a little bit of a technical slide, but an important slide. I'm incredibly proud of how the IBM team has responded, particularly to someone like me, an outsider, a relative outsider, coming in and saying, we're going to drive the hell out of it. So some quick things. The system that played Jeopardy was a single user system. Today we have tens of thousands of people now. In fact, by the end of 2012, the concurrent users. The system that played Jeopardy, only input it could take was 3 sentences. That was the length of the Jeopardy question. Electronic medical record could be 15 pages. So Watson today can take 20 pages of input and understand it versus 3 pages 2 years ago. It used to take 5 days. Anytime I added any content to Watson, I had to bring the system down for 5 days to retrain it. Now we can do that in a couple of hours, and soon we'll be able to do it real time. Again, the system, like I said, that played Jeopardy was the size of a master bedroom. As of 2 months ago, it was the size of a double-door refrigerator. And by the end of this month, it will be the size of a single server. That scales on demand. And pound for pound, it is 240% faster than the system that played Jeopardy back in February 2011. So it can now scale on a cluster-like architecture, like a sprayer architecture, like eBay does. Right? Text-only input, Watson can now understand tables. Because we're taking into insurance, you have to understand tables and understand what tables are. Soon it will start understanding images. Things like, here's another important piece. The system that played Jeopardy was a question-answer system. But a doctor, when he's diagnosing you, may have 6 questions in a row, more of a conversation model. And then you have to be able to manage the state of the conversation, like a search graph over information. So just like you manage transaction integrity, you have to manage information flow integrity. I don't mean to get too sort of into the technical side, but that's a big technical advancement that we have done over the last 2 months. But again, I promised I won't make it an IBM advertisement, but this is actually more about my team and the team that I'm so proud of what they have done just in the last 18 months, not IBM per se. We sell this as a cloud-based delivery model, so you can have it as a cloud. So WellPoint, which is one of our largest customers, nation's largest insurance company, runs this in 4 different states today, and it runs out of Richmond, Virginia in an IBM data center. MD Anderson Houston, which is another client, runs it as a private cloud off of their own premises. Our pricing model for Watson is outcome-based value pricing for healthcare. We get to keep 1/3 of the value that we create for the customer. I'll give them everything that they need. I give them hardware, software, services. I get to keep a third of the value that they get. It's like GE selling you engines by the flight hours, not by spare parts and labor and technology. Right? That's the model for healthcare. Later this month, we'll be launching a Watson product, which will go across the contact center market. That will be a standard SaaS offering, per month, per subscription, per member kind of a model. Every call center in the world could use a Watson. And we're beginning to have that as the next product to be announced in the next couple of weeks here. And the demand for that has been just incredible. So, like I said before, some of the proof points here in medicine, and these are not a stretch of the imagination. We did a project at MD Anderson last year with Watson. We applied it to cancer care. Today, cancer is a big data problem. Okay? It takes about 3 years today to get all the genomic data, manage it to different trials, understand the responses and comorbidities and reactions that people are having to the trial, and then come up with a new therapy. That's what MD Anderson told us. So we took one cancer type, called MDS leukemia, and put Watson to work on it. At the end of a 7-month project, they came back to us and told us what took them 3 years to come up with a new medicine can now be done in 8 months. Okay? I consider that to be the single most important professional achievement of my life. That means it's going to impact millions of people that I'll never meet in my life who are going to get therapies faster because of these technologies that are, again, this is like the desalinization plant. There are lots of data, I don't know how to read it, but a machine can start understanding and giving you assistance on how to come up with new medicine. We are on track to be one of the fastest growing businesses in the history of IBM, and again, a lot more to come on this. So as you look at these examples, I hope you will forgive me when I say that I believe this is the next big inflection point in humanity. Not just an IBM statement, it's an IT and an industry statement. The first swing or inflection for humanity was when we discovered alphabets back in Sumeria. Next one was the printing press. The one after that was the internet. I believe the internet again was about just information, not knowledge. What we are finding now is we are at the very early stages. This is a 20-year shift. We're in the very early stages of machines being able to capture the knowledge of human beings and the next generation being able to print on that and continue to. So in one way, I like to tell my kids that when I'm dead and gone, all I leave behind are you guys and what Google says about me, right? We are the first generation that will leave that behind. Generation before us, when the internet was not there, they would have been in the vacuum. 50 years from now, they would not either have not existed. But ours is the first generation that will leave behind a digital exhaust. With Watson, you'll start leaving behind a knowledge exhaust. And I believe there's going to be another big curve in the next 50, 75 years. And that's why I talk about the difference and the implication of this whole new class of cognitive computers, not programmatic computers. So I'm going to skip through some of this. We have 14 versions of Watson today. We're finding that nurses, again, I had a lot more time if I would have gone through it, but in essence, in the last year, we made Watson smaller, smarter, and more scalable. Okay? It has the knowledge today of a first-year medical resident student. There are 14 instances of Watson running around the world right now, and then we've proven some pretty impressive stats in terms of the business implications of this. What's next is the call center and the client engagement product. Well, one of the reasons we're going after this is the amount of information that people are sharing about themselves is going up, but companies are not able to engage. And at the same time, I'm telling you on Twitter and Facebook and everything what I like and don't like, but people are not able to respond to it. So we believe Watson as an assistant for either self-service or as a contact center technical support person agent would be the next big product for us. And these are things that look for it later in the month, announcement of it. Beyond that, I mean, the opportunities and the applications are limitless, right? We are running this like a startup. The strategy for Watson is establish, extend, and embed. Establish in one vertical healthcare, extend across verticals to call centers. Second half of this year, I'm planning to open up Watson as a platform, so those of you in this room can start writing applications on top of it. At the end of the day, IBM was being smart. We're not smart enough on IBM to be able to figure out all the world's problems. It's you all that we will start opening up this notion of a Watson accelerator that you can start writing applications on it, and we will give you the cognitive power to be able to power a whole new class of systems. So how do we benefit from this? Clearly, like I said, this is the third shift in computing. IBM started off as CTRC, computing, tabulating, and reporting company. We used to do cheese grinding, the cheese weighing machines, the meat slicers, the punch card, that's where IBM started. Then, we're in the era today of the programmable systems. The machines do what you program it to do. The cognitive systems, machines learn and understand and improve over time. Another important thing of the cognitive machines, these are machines, unlike traditional IT systems, the value of this hardware grows over in time, not reduces in time. Current IT hardware, value reduces in time. In this case, it improves in time because it's capturing more information and more knowledge and you're able to leverage it more. So again, where can we all leverage it? I took the liberty of taking a local company here, Kingway, who is in the back-end as a service business. They have this great chart on their website which showed all the players in the cloud space, from platform as a service to infrastructure as a service to mobile services and SDKs and all. You look at the ecosystem. These are all the building blocks of what will eventually become a cognitive cloud, not just a capacity cloud, but a cognitive cloud. And tremendous opportunity. I believe in the next 5 years, we are going to see a tremendous amount of innovation at the intersection of big data, social, mobile, cloud, and millennials. We expect a different kind of interaction. So, last line on this, just a little bit of humor on this part. I believe the era of Homo sapiens is over. It will be replaced by this notion of a Homo digitus. It's someone else's word that I picked up. But if you really look at what's going on, the mobile phones and Google Glasses and where things are going to is augmented knowledge, augmented information, right? This notion of from the hand to the cloud and back, that's where all of us are moving. And the power of putting a technology like Watson bi-vertical into the cloud, so that whether it's through your mobile phone or through your Google Glasses, to power this knowledge, to democratize medicine, to democratize education, democratize security. That's where over the next 10 years you will see some innovations, and tremendous time to be an entrepreneur, and makes me want to change my jersey and jump back into the fray. So again, thank you for the opportunity and the time, and appreciate you guys staying back a little longer.